A little bit about me. I work at CloudBees on scaling the Jenkins platform. We are a company behind Jenkins. We do like enterprise features for Jenkins and so on. One of the things I've done is the Kubernetes plugin. So if you don't know Kubernetes, you can leave now after the whole day. And I also contributed to other Docker-related things like Docker images, official images for Maven, the Jenkins image, and a few other things. And I'm a long-time open source contributor, both at the Apache Software Foundation, Apache Maven, Eclipse Foundation, Puppet, you name it. I've done a lot of work. And I'm part of the Google Developer Experts program for the work we are doing on Kubernetes and container engine. So who is using Docker here today? A lot of people. Kubernetes? Oh, a lot of people. Who's seen the demo from Microsoft this morning? It was like the third keynote with a Jenkins pipeline deploying the Cocodrile. Everybody has seen that because it was a keynote. OK, so that was something I wanted to show you. So obviously, I had to change my presentation. And I'm gonna improvise a little bit here. So if you like that, I'm glad, and it's a great way of showing what you can do, how you can build a pipeline. Who liked that demo? OK, good. Everybody liked that demo? Like what I'm here for. And I'm the only thing between you and beer, so I'm gonna try to be brief. So what we are here for, Docker, everything is Docker, everybody wants to do Docker, even people that don't know what Docker is want to do Docker. They just don't know it yet, right? And I love this tweet, the solution Docker, the problem doesn't matter. And today, you can also switch Docker for Kubernetes. I think it applies the same way. But what we have to try to accomplish is what's on the left side, not what's on the right side. There's a lot of people that are trying to use tools without knowing, just hearing like sirens and trying to use containers in whatever way. But it's Docker. I should use Docker, and you have to provide me like Docker support. OK. And the other thing you have to try to avoid is monolithic microservices. Microservices is another great word that you obviously know about. Because if you don't know microservices, like find another job somewhere, retire with no internet connection or somewhere. So the things we have done with Jenkins, in order to, who's using Jenkins, by the way? I haven't asked this. Pretty much everybody. Who likes Jenkins? It's a tricky question. Yeah. If you don't like, if you say you don't like it, I'll hold you here for a while, and then it'll take longer for you to get beer. So there's two options. You can add more build agents or agents, Jenkins agents for each master, Jenkins master that you have, or you can add more masters. Solution number one, there's a lot of plugins that allow you to add more Jenkins agents. There was, back in the day, it was like EC2 plugins. Any cloud provider has their own plugins to add Jenkins using VMs. And of course, now there's a number of Docker plugins that allow you to create containers and to run Jenkins agents on containers dynamically. So you don't even have to pre-provision anything. There's some problems with this approach. Like the master is still a single point of failure. And also the number of agents, I mean, it reaches a point, I think it's like a few thousand, where it can be a problem. The other solution to have more masters, it's good because you can have different like departments of sub-organizations to have their own master. So it's like sharding. And especially they can have their own plugins, they can install whatever they want, so you can have like different permissions, allowing them to do some things that only affect their team. The problem is like you miss like things like single sign-on or centralized operation. And that's one of the things that we are, my team was working on what's called Cloud-based Jenkins Enterprise, where we provide the tooling and the services and the application layer to syndicate a lot of Jenkins masters, connect them to one place where you can, we call it the operations center, where you can manage and create new Jenkins masters on the fly. Everything runs on container and so on. And I think I have to say that we are recruiting, right? Yes? Okay. And we also are selling. If you have to buy something, then we'll talk later. So what can you do with Docker and Jenkins? You can run Jenkins on Docker. There's some images in the Docker Hub. You have the official Jenkins image, which is like the long-term support release. There's also another one called Jenkins CI/Jenkins, which is the one we built in the open source project. And it has weekly builds, same as Jenkins. And you can also, we have tags for long-term support releases. And you can run Jenkins agents using this JNLP slave Docker image. So you can connect, this is like the base for any Docker agent that you run on Jenkins. This image basically has a small client that connects back to the Jenkins master and advertises itself as a Jenkins agent. There's Docker plugins that will do this for you. There's several. There's the Docker plugin. There's yet another Docker plugin. Naming is always funny. There's a small drawback. There's no support yet for Docker Swarm, like the new Docker Swarm mode. But it allows you to have build agents and isolated jobs, and you can run your jobs in there without affecting other jobs. You can have different images or different software installed in different agents. It's cool. And then we have a lot of other plugins to do different tasks. You can build Docker images. You can connect to the Docker Hub and react to notifications, like trigger a job whenever an image change upstream. You can also trace images, assign like it's like a SHA, and see what's the precedence of each image. And it has great pipeline support. If you know what pipeline is, everybody, anyone using Jenkins pipelines? Okay, well, then you just saved yourself 5 minutes for beer. So I won't go through that. Yeah, so you can do something like Docker image, pull the image, use private registries, and execute things inside the container. So the problem is when this one Docker machine is no longer enough. Now you need to run Docker across multiple hosts. You want to run it maybe in a public cloud, in private cloud, in bare metal, anywhere. You need a cluster. You need a cluster that is running HA. You want it to be fault tolerant. Obviously, who doesn't want that? Even people that don't need it, they want it. So this is another great quote. To make error is human, to propagate error to all service in an automatic way. That's what DevOps is. And I have a version of this after some incident we're not going to talk about here, not in public at least, is if you haven't automatically destroyed something by mistake, is that you are not automating enough. Trust me. You have to automate to the point where you break something. And then you can say like, oh, OK, I just reached this point of maturity where I can break things automatically. Then it's like, oh, that's like at the next level. So the options, you had to run a cluster of containers. People talk about Mesos. People, I guess somebody talked about Docker Swarm and Kubernetes. A lot of people talk about Kubernetes. I'm not going to go into the details of each of them. Just focus on Kubernetes. And as people said, based on Google experiences, allows you to run. You can run Kubernetes pretty much anywhere, bare metal, cloud providers. Google gives you the container engine on Google Cloud. There's other services that will provide Kubernetes as a service. And one cool thing that I didn't hear mentioned today here is that you can find Minikube for local testing, which is like a small VM that you run on your machine, and it will give you like a 1 VM Kubernetes cluster for testing. We use that for the Kubernetes plugin, and it's really cool because you can run all the tests there pretty fast, and you can like throw it away whenever you want and start from scratch. So it's a great way to use it. One of the cool features of Kubernetes that other providers didn't have, other cluster didn't have, now Swarm does have it, but they started doing what they call pods. So for this continuous integration, continuous delivery, what this allows you to do is you can compose different images instead of building your own. Instead of having to build one image that has all the software that you need to run a build, a test, or a deployment, whatever it is that your job runs, instead of having one image, build it yourself, you can have a pod, a group of containers that has all these different things and reusing images that somebody else did for you. So you can have a pod that has the Jenkins agent because you need that to connect to be able to run jobs. You can have a container that uses the Maven image to do a Maven build. And this is like an example on Selenium. You can have another image that another container running the Selenium hub, another container running the Firefox browser, another container running the Chrome browser. So now your agent to run this job can be 5 containers, or whatever number of containers you want. And because the way Kubernetes works, these containers can find each other under local host. So you can, and I'll show you an example how you can run like a simple Selenium test using a pod and without writing any custom image. And for Jenkins, you have the masters that need the persistent storage, is where the logs, the jobs, all this stuff is stored. The agents typically don't need storage. Well, we can talk about workspace caching and other like cool features, but it's a bit advanced, I guess. So you can create easily with Kubernetes. You can create persistent volumes. In different clouds have different providers like GCE or AWS EBS volumes or NFS, anything like that that Kubernetes supports. You can use it as a local volume. And there's some caveats when you run things. Obviously, you should not run things as root. And when you run things in a container, you got to make sure that the user ID matches the host or whatever thing that you are mounting. There's a lot of issues reported by users that run Jenkins and try to mount like a host volume into the container. Because the Jenkins image by default runs as user 1000, it drops privileges from root. People complain about permission issues. So you got to make sure that even if the name matches, that doesn't matter, the username. What matters is the user ID. So whatever volume you mount as a Jenkins home, you got to make sure that it runs as user 1000, or you change the user that your container runs as. But the easiest way is run your volumes as user 1000. And the same applies to other images. Things run as different users. You got to make sure that whatever volumes you use have the right permissions. In Kubernetes, there's the security context FS group option. So whenever I want to run Jenkins in Kubernetes, I set that. And when it mounts a volume, it makes sure that's writable by the user 1000. And that's, well, the description of it. About networking, the Jenkins masters expose like HTTP and the JNLP port where agents connect to. JNLP is the protocol that agents use. They also use expose like an SSH server port, so you can SSH into Jenkins itself and execute some commands. It's not widely used. I guess it's not very useful. I don't know. I haven't used it, but you can do that if you wanted to control remotely. And the agents connect to the master. You can choose between SSH or JNLP. In cloud, some clusters typically, well, you want to use JNLP because SSH, you would need to open the agent ports of each agent. With JNLP, basically, the agents connect to the master, so you only have to open the ports in the master. You have multiple networking options on Kubernetes, and the cool thing is whenever you define a pod, the containers in the pod can connect to each other using localhost, so you don't have to do any service discovery inside the pod itself. When you run in a cluster, there are some things that you have to consider, especially Jenkins or continuous integration or continuous delivery is a very interesting case because you basically allow people to run wherever they want. You allow them to run a shell script, you allow them to run a make build, you may even allow them to install packages in the image. They can do pretty much whatever they want. And if you try to limit, I'm sure you're going to get calls from other people trying to use it saying, why cannot I do this? Why cannot I do that? Why cannot I execute a shell script? And so on. So when you run in a cluster, this Kubernetes allows you to set both memory limits, CPU limits using quotas. And you can basically that way prevent people from oversubscribing or using all the resources available. Now, when you run Java applications, there's some interesting facts you need to know about memory. And this is not just Jenkins, but any JVM application. So I'm going to show you a demo now. Okay. This is a Maven build, but this would apply to any JVM thing you run. But it's specifically useful to learn it with build tools and Maven. So this is a test that basically just uses memory, then garbage collection happens, memory goes down, uses memory, garbage collection happens, memory goes down. I'm running this just the Maven image. Oops. Well, I'm doing some tricks here to share the Maven repository so it doesn't have to download the internet here for each time I run it. So this is just running the Maven image and running a Maven build. No memory limits, nothing whatsoever, okay? You saw it continues running forever. So let's try a different thing. And I'm going to run it with a limit of memory of 220 megabytes. So what do you think is going to happen whenever this runs out of memory? Because this was using more than that. So any ideas? Who thinks it's going to throw like an out-of-memory Java exception? Raise your hands. Nobody. Everybody's shy. Who has any other ideas? No ideas. You're cheating. You already saw this before. Any ideas? No? Nobody? Nothing? Okay. You really want the beer. Okay. So this is what happened. The process just finished. No indication whatsoever of what happened. Okay. So there's nothing there, nothing printed, nothing. You only get to see something when you run a command called docker inspect. And if you find this flag here, it's a very interesting, with a very useful, scary name. Where did I do it? Okay. OM kill true. This is basically saying your container went over the amount of memory that was allocated to it by the kernel, and the kernel killed the process. And if you were paying attention during the whole day, you know that containers are just processes and so on. So this is basically what happened. You set a limit to the kernel enforces the limit of the memory. Your container went over it, and it killed it. You may wonder, why didn't Java, the JVM? I mean, I don't have to clean memory after myself. The JVM will do everything. Well, this is because, by default, the JVM sees how much memory is available at the host level, not at the container level. And typically, it will use 1/4 of the memory it sees as the XMX value, like the max heap value. So this actually here somewhere, it says, oh, I have 444 megabytes available. Sorry, it's probably seeing like 4 times as that. It's probably seeing 2 gigs. And it says like, oh, let's say max memory 444, max heap. And it continues using memory until that. But before that happens, the kernel sees that there's more memory in use, and it gets killed. So there's some things that you can do. And this is very application specific. Basically, you have to pass to the JVM a limit saying how much heap memory you want to use. And in this case, the next run I'm going to do, actually I'm going to do it now. I'm saying, OK, memory limit is 220, heap size 210. So what's going to happen, this is Maven opt, is specific to Maven. Different applications have different environment variables to pass values to the JVM. And this is basically instructing the JVM. And you see that the JVM is using 187 as max memory. So this is a way to tell the JVM, don't use more than this memory. And this is going to continue running forever. It's going to do more garbage collection more often, and so on. But the problem is this is really a pain in the ass to have to configure every app that you use, or every tool like Maven, Ant, or Gradle, or whatever. So there's other options just recently, but I think actually, but I'm going to show you something else because I was cheating a little bit. So by default, Maven forks when it runs the tests, it forks into a new virtual machine. And in that case, I was not forking. I just explicitly tell it to not fork, so it was running one process. If you run the default, you're going to hit one process for Maven, and then it's going to spawn out at least another process for the tests. So even if I set Maven opts to 210, what's going to happen is this. You get, at least now you get a kill message, and Maven is telling you the 4 VM terminated with saying properly goodbye. So what happened here is Maven had a memory limit, but then it spawns another JVM process. The new JVM process doesn't have a memory limit. It sees all the memory of the host. It tries to use more than it can. And that process dies, and then Maven notices the process has died. Now, a way to fix this in a generic way, is underscore Java options. Basically, this tells the JVM to, whenever you create a new JVM, use these options as the default. So it saves your bacon for some time. Obviously, if you start too many Java processes, each of them is going to use this limit, and then some of them may get killed. But this would work for this example at least. And now there's, well, okay. Luckily for us, there's a new support in Java, in the JDK 8.131 and JDK 9, where you can use these options here. You can use the use cgroup memory limit, and instead of seeing the host memory, it's going to see the container memory, and it's going to use 1/4 of that, and not 1/4 of the host. So I wrote a blog post with different examples, and if you use also the max RAM fraction 1, you are telling the JVM to use, instead of 4, which is the default 1/4, this is 1, which is use all the memory. So if you're not running anything else in the container, you can set max fraction equals 1, and then it's going to use the container memory as the heap memory. And supposedly there's going to leave some room for other memory that is not heap memory. But obviously, if you run native things, you're going to go over the limit. But this may work in your use case most of the times. And you can also set CPU limits. Who thinks, any ideas what's going to happen if you set CPU limits and the container runs over them? Nothing? Nothing? No ideas? Well, nothing will happen, basically. Kubernetes separates what requests and limits are, and then it passes on to Docker as CPU shares and CPU quota. So when you when you set requests, basically you are telling a weight. So this container has a weight of 1. You can run another container with weight of 2. And if you run them together, they're going to split. One is going to get half time CPU than the other one. It doesn't matter what you set here. If you only run one container in one machine, it's going to get 100% of the CPU. So it's always at relative weight between processes. CPU limits, on the other hand, is translated to CPU quota, and then there you can set how many cycles of CPU your process gets. But nothing bad is going to happen. It's just going to run slowly, or nothing as bad. OK. So I think I'm going to just jump to show you demos. So one of the things I've done in the Kubernetes plugin, well, one of the many things. Dynamic agents, you can run dynamic agents as pods, multiple containers, as I mentioned, and also pipeline support, and you can attach persistent workspaces using Kubernetes volumes. And let's see, what do I have here? Maybe it's OK, so I created a job, and I can write a Jenkins pipeline and say pod template, and say a label. I can call it whatever I want, container day. And inside, I can set a Jenkins node. So basically, use a node that has the label container day. If I could type, it would help. Oh, God, I'm dyslexic today. Container day. And I can run sh hostname. OK, it's been a long day. And I can run this. Actually, I'm going to show you in the new UI, of course. Container day. This is the first one. And I'll make it bigger if it works. Yeah. So it's telling me, well, this is running on this. This has this host name. Let's look at what Kubernetes is telling us. It's too late. It's already killed the container. Okay, so let's do it again. This is the pod that is running the Jenkins, the first one. And the second one is the slave that was just created. And it's running the shell script that I pasted in, and then it disappears. So this is running on demand on your Kubernetes cluster. You don't need to do anything. It's all magic, the good kind of magic. So let's say I want to do something a little bit more complex than this. Okay. By the way, this is running on Google Container Engine. In a cluster that I created using Kubernetes 164. Basically, you can easily come here and create a new cluster whenever you want. And okay, so other examples that I have. Multi-container, yeah. Let me show you the pipeline that I've run here. Maybe it's too big. Multi-container. So what I have here, it's maybe. All right, there is better. So I have defined a pod template. I can do this from the UI, filling a form, and in the Jenkins configuration. But I can also do like as another thing that is very trendy today, which is CI as code, where you basically write this and you can check this in your Git report, Subversion, whatever you use. And I'm defining a pod template with two containers. One is Maven container, the other one is a Golang container. And the Jenkins agent is implicitly always in there. You can override it, but it's implicitly there, so you don't have to create it. Doing a little trick here, again, so it doesn't take forever to download the Maven repository. I'm saying this is a disk that I have pre-populated with all the Maven cache, with all the Maven artifacts. And I'm mounting it under the root M2 repository for the Maven containers to find it. And there's only two things that are a little bit weird here. I'm setting that command for both Maven and the Go containers as cat, because if I leave they don't have an entry point or a command, or if they have, it finishes, and I want the containers to keep running, okay, while my pod lives. So I'm basically run whatever it is, I don't care, but it has to keep the container running because I want to execute things into that container. This may be simplified in the future. So another thing that the Kubernetes plugin provides is this container step. Basically, I can say, go into the Maven container and execute something. So I can say, go into the Maven container and run a Maven package. And here, I can say, go into the Golang container and execute this shell script. This is like a make file, calling a make file in Go. And I have the stages. This is the normal. Everything is a normal Jenkins, like a pipeline node. I choose what node to run on by label. I create some stages. I pull sources from Git. But then I execute into the Maven container to run something. I execute into the Golang container to run something else. I don't need to create an image with Maven and with Go. I just use whatever is there. And that looks like, well, in a pipeline, it looks like this. The checkout and the Maven clean package, it just executes into the Maven container. Nothing special there, runs the test and everything, and then it goes to the next stage and does the same thing in the Golang container. The example I was talking about before with Selenium. So this is doing more or less the same thing. I'm running a Maven build, and this Maven build executes a Selenium test and basically looks for Selenium hub running on localhost. I'm running the Maven container, I'm running the Selenium hub container, I'm running the Selenium Chrome container, and I'm running a Selenium Firefox container. So this is providing me a Selenium hub with Chrome and Firefox support, and then I run my build and point to localhost 444, and I can execute my Selenium tests, no problem. Maven image, no problem here. The Selenium hub, no problem. The Selenium Chrome image, I'm still reusing everything that is public in the Docker hub. I don't have to build any new image. The only thing is, like, these images are designed to run with Docker link and expect some environment variables. That's why I'm setting here the address is localhost. So this is how do they connect to the hub. And they expect these variables to be there. I'm just saying the hub is in localhost 4444. And because the containers in a pod share the network namespace, whenever you try to start, they try to start XVM, virtual frame buffer, you need to assign different values to the display variable so they don't have collisions in the ports. And the same thing for the Selenium client that they run. They have to run it in different ports because, remember, this all runs in the same namespace. So once I have that, I can say, OK, check out my Selenium example with my tests and run in the Maven container, run the Firefox and the Chrome tests. And this one is doing it in serial, but I had another example. I don't know why it's not the last one, where I've done it. You can do it in parallel too. It's just really annoying to find things in the screen that big. OK, here it is. I'm going to run it, and I'm going to show you. Because what I've done, instead of waiting for both to run, what I've done is creating two Maven containers, one to run the Firefox tests, one to run the Chrome tests, instead of just having one. And I'm using the parallel step in Jenkins. So I'm saying, run in parallel Maven, passing a variable, Selenium browser is Firefox, and in parallel Maven with Selenium browser is Chrome. So these two tests are going to run in parallel. And you can see, hopefully, here. Well, it was still scheduling the task. So I'm reusing all the images that are publicly available in the Docker hub. I'm running Maven against Firefox, Maven against Chrome, all together in parallel. So you can see I get the Firefox ones and the Chrome ones. And this is going to be an intertwin messages from Maven building the same thing in different places against a unified Selenium hub. So it's an interesting case for multi-container. You can also run Docker builds if you want to, like building Docker images. Docker. The only thing basically is is not great, but that's the way it is with Docker nowadays. You can mount the Docker socket and use the Docker image that is in the Docker hub, where it has the Docker client installed. So you're executing things in the host. That's what is not ideal. You're basically bypassing everything, and if you pay attention also this morning, you shouldn't do it. But if you want to do it, you can do it. I'm checking out a Docker image, a Docker file, and I'm running just Docker build. And this is working fine. There's no problems other than you have to trust what people can do once you let them access the Docker socket. And I think the last one, yeah, it's how can you deploy to Kubernetes itself. There's some pipeline libraries out there. I'm going to run it first, and I'm going to show you the pipeline. I'm using a library made by the Fabricate people, Red Hat, and I'm saying from source control, deploy this Hello World version 1 YAML, and then I'm creating another stage that is upgrade, where I'm asking you to approve the upgrade, and then I'm deploying another version 2. So this was running. So basically, it's waiting for me to approve the upgrade. Let's see where this is going. CTL, get all. So I just deployed the version 1 to Kubernetes of very simple app. I have 10 pods running here. I have a service exposing it to the outside. I can check. You see, hello Kubernetes 1.0. So let's do well true. Do echo down. Let's sleep 1. So this is, I just deployed version 1 of my application, and it's working fine. And I can say, OK, just approve the upgrade. This is going to execute another Kubernetes command that it's going to deploy the version 2. And Kubernetes itself is going to do the upgrade of the pods, killing pods. I can see the output that doesn't say much. The upgrade went through. And some pods are already answering Kubernetes version 2.0, while other ones are still serving 1, and the upgrade at some point finishes. So I think that's it. You can go prendre la bière maintenant. Hein? So, s'il y a des questions.